adding and subtracting fractions using the ladder method to find the least common multiple or finding the common denominator. So with the ladder method, remember you're going to write the numbers that you're finding the least common multiple for in a line. And in this case, I need to find a common denominator for 42 and 18 in order to subtract these fractions here. So I'm going to line the two denominators up and put a little box around the two numbers. Then what I'm going to do is divide out common prime numbers. So when they're even, I start with 2 and I put 2 on the outside of the box and divide it into each number. So I end up with 21 and 9 once I divide it out of 42 and 18. And I'm going to continue until there's no longer common factors. So 21 and 9 have a common factor of 3, so I'm going to put 3 on the outside. I'm going to divide it into 21 and 9, and I'm going to end up with 7 and 3. There's no common factors in 7 and 3, so the least common multiple will be the numbers on the outside multiplied together. So I'm going to do the side two numbers together. 2 times 3 is 6. The bottom two numbers together, I'm going to get 7 times 3 is 21. And then I'm going to multiply 6 to 21. So I find my least common multiple for 42 and 18 will be 126. So now I need to convert these fractions to have the common denominator of 126. At this point, to convert the 13 over 42 to have the denominator of 126, I need to multiply 42 by the number that will give me 126. Well, when you use the ladder method, the number that you're going to multiply by is always going to be the bottom diagonal number. So when I multiply 42 by 3, I will end up getting my least common multiple of 126. So when I multiply 42 by 3, I need to also multiply that 13 by 3. So when I multiply 13 to 3, I end up getting 39. So now the bottom diagonal number to 18 is what I multiply by to get 126. 18 times 7 will give me 126. So whatever I multiply the denominator by, I need to multiply the numerator. So in this case, I have 5 times 7, and I get 35. So now I have the common denominator, or like fractions, so now I can subtract. I'm going to subtract 35 from 39, and I'm going to end up with 4 over 126. Now be careful, you do all this work, if you don't simplify your fraction, you're going to end up with an incorrect answer. You always have to reduce fractions. And when you see an even number over an even number, you know that 2 will definitely divide out of each number. So when I reduce here, I'm reducing both numbers by 2, and I end up with my simplified fraction is 2 over 63. Pause and try. I'm using the ladder method here to find my least common multiple, and in this case I have 12 and 20. I divide 2 out of each, I get 6 and 10. I'm doing 2 again, I get 3 and 5. Now I have no more common factors. I multiply the sides together, the bottom together, and then I multiply the 4 times the 15, and my least common multiple here will be 60. Now remember the bottom diagonal number. So the bottom diagonal number to 12 is 5. I'm going to multiply 12 by 5 and 5 by 5, and I'll get 25 over 60. For the 20, I multiply the 20 by 3, so I have to multiply the 1 also by 3, and I get 3 over 60. Now I have like fractions, so I can add the numerators. I get 28 over 60, and I can reduce. So please make sure that when you reduce until you get it in simplest form. So I chose to use 2 the first time around, and you see that I have 14 over 30, and 2 comes out again. If you knew that 4 came out directly, then you could have just gone there to the 7/15. Pause and try. So I'm using the ladder method. I'm finding the least common multiple. And in this case, when I found the least common multiple, I ended up with 8 times 6, which is 48. So now I have my common denominator. Now notice I brought the signs that are with it down because signs matter. It's minus 5/16, so it's going to be a minus whatever over 48 and plus whatever over 48. So now the 16, that bottom diagonal number is 3, so I'm going to multiply the numerator and the denominator by 3. So I end up with a negative 15 over 48. The 24, I'm multiplying by 2, so I need to multiply that numerator by 2. So I end up with 2 times 1 is 2. Different signs. Remember, with different signs, you always have to subtract and keep the sign of the higher number. So in this case, I end up with a negative 13 over 48. So this next example, notice here I'm adding a whole number to a fraction. Well, whenever you're working with fractions, you always want to work with fraction to fraction. So this is going to use that property of 1, which states any number can be put over 1 and it becomes a fraction. So in this case, I put 3 over 1. So now I have fraction to fraction. And whenever you have fraction addition, you always need a common denominator. So the denominator is always going to be the denominator of the fraction. So I want to leave the denominator of the fraction the same, but that 3 over 1, I'm going to need to multiply the denominator by 7 in order to get a denominator of 7. And whatever you multiply the denominator by, you're going to need to multiply the numerator. So I end up having 21 over 7, and then the 6 over 7 just comes down. Now you have your common denominator, so you can add the numerators, and you end up with 27 over 7. Leave it as an improper fraction. Pause and try. So you're going to put 8 over 1. You're going to get a common denominator of 10, and then you're going to have to multiply that 8 over 1 by 10 over 10 to have that converted fraction. And then the 1 over 10 just comes down, and it's subtraction here, so you end up having 80 minus 1 is 79 over 10. Pause and try. So in this case, I'm putting that 7 over 1. I need to get a common denominator of 11. I multiply 7 over 1 by 11 over 11. So I convert the fraction to 77 over 11. Notice here I have different signs. Different signs mean I have to subtract and keep the sign of the higher number. So in this case, I end up with a positive 72 over 11. So this next example is an example where we have variables in the denominator. So when we're adding fractions, even when there's variables in the denominator, you must have the same denominator. They must be like fractions. So when I'm looking for the common denominator, in this case, I need to find the least common multiple for 18. So you can work it by using the ladder method, and you should find that the least common multiple for 12 and 18 will be 36. But because they both have x in it, the least common multiple is also going to include that variable x. I need to convert these fractions to get the common denominator. So with 12, I multiply by 3 to get 36x, and whatever I multiply the denominator by, I have to multiply the numerator. So I end up with 33 over 36x. For the second, I need to multiply 18 by 2 to get 36, so I end up with 36x, and whatever I multiply the denominator by, I have to multiply the numerator by. So I end up with 14 over 36x. And in this case, we're subtracting, so I subtract, and I end up getting 19 over 36x. Pause and try. So you should have used the ladder method to find the least common multiple here, and you should have gotten that it's 30x. So we get 30x as my common denominator. I multiply the first fraction by 5 over 5. I get 25 over 30x. I multiply the second fraction by 2 over 2, and I get 8 over 30x. So here you end up getting 17 over 30x. Now this next example, we're going to be working with combined like terms with fractions in it. So remember, like terms have the same variable with the same exponent. But like terms can also be constants. And in this case, my constants happen to be fractions. So the first thing I'm going to do here is rearrange it so that I have my like terms together. So I end up having 5x minus 1/3 x. And I have a minus 1/2 plus 2/5. So I'm just rearranging so that I can see what I need to do to combine it. So I'm just working with the first part. I have 5x minus 1/3 x. Well, in this case, in order to combine it or do the arithmetic, I'm going to need to get a common denominator. So I really have a whole number minus a fraction. So remember, when you have a whole number minus a fraction, you're going to make that whole number a fraction by putting it over 1. Now you're going to get a common denominator, and the common denominator is going to be the denominator of the fraction, and in this case would be 3. So I need to convert 5 over 1 to have a denominator of 3 by multiplying the numerator and denominator by 3. So I convert the 5 over 1 to 15 over 3x minus 1 over 3x. Now I can combine the like terms. So I end up doing 15 minus 1 is 14. 14 over 3, and make sure you don't forget to attach the x. So I combine like terms by getting a common denominator. With the second half, I'm going to get a common denominator. Now notice in this case, to get a common denominator, I'm going to need to convert both fractions. So to convert both fractions, I'm going to have to multiply the fractions by the number that's going to get me that common denominator. And notice here that 2 and 5 are prime numbers, and the only way to get the common denominator is to multiply them together. So I end up getting a common denominator of 10. So the first fraction I'm going to multiply by 5 over 5, and I'm going to end up getting a negative 5 over 10. So the second fraction I'm going to multiply by 2 over 2, and I'm going to end up getting plus 4 over 10. So now notice here, when you do the arithmetic, you have different signs. Different signs mean you need to subtract and keep the sign of the higher number. So in this case, we have a negative 5 plus 4, so we're going to end up with minus 1 over 10. So this is in simplest form. I combine like terms, and this is what I get. Pause and try. So I always like to rearrange it so the like terms are together. So I need to get a common denominator for the negative 7m and the minus 2/5 m. And the common denominator is going to be the denominator of the fraction. So I'm going to convert that negative 7 over 1 by multiplying the numerator and the denominator by 5. So I end up with negative 35 over 5m minus 2/5 m. I have a common denominator. Same sign means I'm going to add and keep the sign. Make sure you attach that variable. And now you simply have integers. 2 minus 4, when you combine, you end up with a minus 2. Pause and try. So I'm going to rearrange this so that the like terms are together. 1/3 x plus 2/5 x. And then you have that minus 1/2 plus 2. I'm going to get a common denominator for my fractions here. And I end up with 5/15 x plus 6/15 x. And I get 11/15 x. And this 2 needs to go over 1. I get a common denominator of 2. I have different signs, which means I'm going to subtract and keep the sign of the higher number. So I end up with plus 3/2.